Welcome to Green Technology. In a world facing climate pressure, resource shortages, and rising waste, some of the most important innovations don't look revolutionary at first glance. They don't glow, they don't move fast, and they don't grab headlines. This is the story of particle board, a material born not from forests being cut down, but from wood that has already lived one life. When wood waste is buried in landfills, it slowly decomposes and releases methane, a greenhouse gas more than 25 times stronger than carbon dioxide. But when that same waste is collected, processed, and reused, the impact changes completely. For every ton of recycled particle board produced, up to 12 mature trees are spared. Forests remain standing, habitats stay intact. What arrives at a particle board factory doesn't look valuable. It's sawdust swept from mill floors, broken furniture, discarded pallets, demolition debris, and wood scraps from countless production lines. Different sizes, different species, different moisture levels, total chaos. Before anything useful can be made, that chaos must be controlled. The first step is purification. Vibrating screens shake away dirt, powerful industrial magnets pull out nails, screws, and hidden metal fragments that could destroy machinery or weaken the final product. What remains is clean wood, still rough, still inconsistent, but finally ready to be reshaped. Next comes size control. Large drum chippers take over, their steel blades spinning hundreds of times per minute. Thick planks, broken boards, and bulky scraps are sliced into smaller fragments in seconds. This isn't just brute force. Integrated screening systems immediately sort the output. Oversized pieces are sent back for further grinding. Inside massive rotary dryers, hot air floods the chamber at extreme temperatures. The particles tumble continuously as moisture is driven out layer by layer. Sensors monitor everything in real time, targeting a narrow moisture window usually between 2 and 8%. Once dried, the particles go through another round of sorting. Fine particles are separated for surface layers, where smoothness and density matter most. Coarser particles are reserved for the core, where thickness and strength are critical. Every particle is now assigned a role. Nothing is random anymore. Inside sealed blending chambers, the particles are coated with resin. Urea formaldehyde is commonly used for cost efficiency and strong bonding. Phenol formaldehyde is added when higher moisture resistance and durability are required. Additional additives enter the mix: wax for water repellency, flame retardants for safety, antifungal agents for longevity. The resin becomes a new bloodstream, allowing millions of individual wood particles to bond into a single structure. Layer by layer, the treated particles are formed into large mats and fed into massive hot presses. Heat and pressure take over. Under these extreme conditions, loose particles fuse into solid panels. This is the point of no return, the moment waste is permanently transformed into engineered material. What entered the factory as scraps now exits the press as dense, uniform particle board. Fresh from pressing, the panels are dangerously hot and filled with internal stress. If left untreated, they would warp or crack as they cool unevenly. Long cooling lines stabilize them. Air flows from every direction, releasing internal tension and bringing the boards into equilibrium. Sensors ensure the cooling process is slow, controlled, and consistent. Once stable, the boards move into sanding lines. Large rollers shave away microscopic layers, smoothing the surface to a level suitable for furniture, cabinetry, and construction finishes. Dust collection systems work constantly, keeping surfaces clean and air-breathable. The difference is dramatic. Rough, industrial slabs become flat, clean, and precise. Before leaving the factory, every board is tested. Laser scanners detect cracks, thickness variations, and warping invisible to the human eye. Random samples are bent, compressed, and stressed to verify load-bearing capacity and long-term stability. Only boards that meet strict international standards are approved. At the end of the line, robotic systems stack the finished panels, wrap them for protection, and label them for full traceability. From here, they'll travel across cities, countries, and oceans, becoming desks, cabinets, shelves, and structural components in homes and offices worldwide. Particle board isn't perfect. It still consumes energy. It still relies on synthetic resins. And packaging remains a challenge. But it represents something far more important: proof that industrial scale and environmental responsibility don't have to be enemies. This material shows what happens when technology stops asking how to extract more and starts asking how to waste less. When you look at a particle board panel, you might only see engineered wood, but behind it is preserved forest, reduced emissions, and a system learning how to give materials a second life. This is green technology, where progress isn't measured by what we destroy, but by what we choose to reuse.